So this is question 3, 2011 Higher Maths paper. In this question, we're given a graph. There's its equation. We don't know what the equation is. Y equals some formula in x. Some changes are made to that equation. Everywhere we have an x in this formula, we've replaced it by x plus 2. We've also subtracted 1 from this formula. So changes have been made to the equation. We need to know what the effects these changes have on this graph. Now, the choices we're given, 1, 2, 3, 4, clearly tell us where these 2 points have ended up. So let's first have a look at an animation. So here we have the graph that's given to us in the question. It looks a bit like a cubic graph. And its formula is y equals f of x. Its equation is y equals f of x. I've highlighted the point 1, 2. It's one of the points that's highlighted in the question, shown on the graph in the question. So, red graph y equals f of x. I'm now going to make alterations to this x, and you'll see a blue graph appearing that's the result of these alterations to this formula. So, let's first of all add numbers to x. Now, the effect this has on the graph is to move it to the left. So let me just try and get it to 2. There we go. I've now added 2 to x. The result is that the graph has moved 2 units to the left, parallel to the x-axis. So adding 2 to x results in a shift 2 units to the left, parallel to the x-axis. So let me put the graph this time with subtracting values from x. And there we go. We're now subtracting values for x from x, and the graph has moved this time to the right. So subtracting 2 from x, the resulting graph is 2 units to the right from its original position, parallel to the x-axis. So let's now just summarize that. When I added numbers to x, the graph moves parallel to the x-axis to the left. When I subtract numbers from x, the resulting graph moves to the right, parallel to the x-axis. Let me just put the graph back to where it was in the original. Okay, now I'm going to add and subtract numbers at the end here. Let me just first of all add numbers. So adding numbers, the whole graph moves up. This time it shifts up, parallel, this time to the y-axis. So adding 2, the resulting graph is 2 units higher. It's moved parallel to the y-axis, up 2 units. If I now do an alteration the other way, if I now subtract, for instance, 2 units, there we go. We've now subtracted 2 units from this formula in the equation, and the resulting graph is now 2 units down, parallel to the y-axis. So in summary, if we add numbers at the end, the resulting graph moves up parallel to the y-axis. If we subtract numbers from the end, at the end, the resulting graph moves down parallel to the y-axis. So remember these. Let's go back to the question. So from that animation, we can see that adding 2 to x moves this graph 2 units to the left, parallel to the x-axis, and subtracting 1 at the end moves this graph down 1 parallel to the y-axis. We can see where the 2 points end up. 1, 2, if we move this point 2 to the left, we'll end up at -1, 1. And the point -2, -3 will end up at -4, -4. So we're basically looking for a graph, same shape, but moved 2 units to the left and 1 unit down. So let's have a look at the choices we were given. There they are, and you can see that this choice, choice D, is the one that we're after. So, choice D.